Today we're going to get started by looking at lesson 8.2, which is about multiplying and factoring. So our objectives today, we're going to multiply a monomial by a polynomial, and then we are going to factor out a GCF from a polynomial. So it says recall distributing one term. So remember, when we distribute, I have something outside of the parentheses. It is going to get multiplied to everything inside of the parentheses. So in this case, 3 times 4 gives us 12, and then there's an x with it. I'm going to bring that addition sign over. Now 3 times 2 is 6. There is an x with that as well. In this case, those are two like terms, so I'm going to combine them. 12x plus 6x gives us 18x. But to distribute meant we took whatever was on the outside and we multiplied it to everything on the inside. So that's the exact same thing that we're going to continue to do. However, it might not just be numbers that we are distributing. Sometimes it could be numbers and variables. So let's take a look at these examples here. We've got 2x times the quantity of 10 minus 5x. So this time it's not just a 2 on the outside, but it's an x. We have to remember that when we multiply, we want to multiply the numbers together, but when we're multiplying variables, if you see the same variable, we keep the variable and we add our exponent. That takes us back to what we were doing in chapter 7. Remember, so here's a quick refresher. If I have x to the power of m times x to the power of n, remember we kept that base and we added the exponents. So that's exactly what we're going to be doing here. So notice that 2x, so x technically has an exponent of a 1. Notice that inside the parentheses, I do see an x. That technically has an exponent of a 1. So it might be a good idea for you to go back and look to see what my exponents are, and then now we can start distributing. So 2x is getting multiplied by 10. So the 2 and the 10 get multiplied. 2 times 10 is 20. And there's still an x. Because there was no variable with the 10, I can leave it just as an x. You can put the little 1 if you want, but it's not necessary. I see that there's a subtraction sign, so I'm going to bring that down. And now I'm going to distribute the 2x to the 5x. So I get to multiply the numbers. 2 times 5 is 10. Now that x gets to get multiplied by this other x. So remember, I keep the x and I'm adding the exponents. So there's a 1 on the outside, there's a 1 on the inside. 1 plus 1 gives me a 2. Because 20x minus 10x squared, the 20x and the 10x squared are not like terms, I cannot combine them any further. I am going to rearrange this into standard form. So because x squared is bigger than x, I got to put the squared term first. That 10 is negative. So when I rearrange it, I'll have a negative 10x squared plus 20x. And here is my final answer. No like terms, it's in standard form. If we take a look at the next example, x to the third is getting multiplied by 2x to the fifth minus 6x squared plus 4. All right, so that x to the third is going to get distributed not once, not twice, but in this case, 3 times, because there's 3 things inside of the parentheses. Because I don't see a number with the x, you can think of it as a 1. So 1 times 2 keeps it a 2. But just like before, because these x's are the same and they're being multiplied, I get to keep the x and I'm adding the exponents. 3 plus 5 gives us 8. I'm going to bring down that subtraction sign. 1 times 6 is still 6. X to the third times x squared. I get to keep the x and I'm adding the exponents. 3 plus 2 is 5. I'm going to bring down that addition sign. 1 times 4. So here, that got distributed to the 4. So 1 times 4 is 4, but there's also an x to the third. Because there's no variables with the 4, the x to the third doesn't change. It'll stay x to the third. Because we have an x to the 8th an x to the fifth, and an x to the third. None of those are like terms. It goes from biggest exponent down to the smallest, so we don't have to do any rearranging. This is my final answer. When I take a look at this letter C, we've got negative 3x squared, and that's getting multiplied by negative 2x plus 7. So I have to distribute 2 times here. I'll start with the fact that negative 3 is getting multiplied by negative 2. So negative 3 times negative 2 is positive 6. X squared gets multiplied by x to the first power. So I get to keep the x, and I'm adding the exponents. 2 plus 1 is 3. I'm going to bring down that addition sign, and now I get to multiply negative 3 times 7. That gives us negative 21. And that x squared is also getting distributed. Because there were no variables with the x, then it's just going to stay x squared. These are not like terms, so you can leave it like that. If you want, you can get rid of the addition sign. You can just write it as subtraction. Either one of those answers I would accept. This is my answer. So I would suggest that you pause the video and try these 2 checkpoint problems. Okay, hopefully you pause the video. I have to distribute 3 times here. 6 times 4 is 24, and then the x gets carried over. Bring down the subtraction sign. 6 times 3 is 18. There's an x on the outside. There's an x on the inside. I'm adding exponents. There's technically a 1 on the outside. 1 plus 2 is 3. Bring down the addition sign. 6 gets multiplied by 1, so that's 6. This exponent is a 1. And so I keep the x and I add 1 plus 1 is 2. I'm just going to rearrange this into standard form. So negative 18x to the third plus 6x squared plus 24x should be my answer. In the next one, I want to distribute that x to the fifth power. So when I distribute that, we've got the 3 still. X to the fifth times x squared. You add the exponent to x to the seventh. The x to the fifth then gets multiplied by 2x. So bring down the 2. X to the fifth times x to the first will give us x to the sixth power. Bring down the subtraction sign. I'm distributing that. X to the fifth times 4 becomes 4x to the fifth. Because there are no like terms, then I don't have to combine anything. And then I notice that it's already in standard form, so we don't have to rearrange anything either. That's my answer. All right, so moving on to the second concept. The second concept is all about GCF. That stands for the greatest common factor. So G is greatest. C stands for common, and F stands for factor. So the greatest common factor is the biggest number that divides each term and the biggest amount of variables that the terms have in common. So the GCF is the greatest common factor, which is the biggest number that divides each term and the biggest amount of variables that the terms have in common. Let's take a look at a couple of example problems here. So we want to find the GCF of the terms in each polynomial. So we've got 6y to the third minus 3y. What I'm going to do is I'm going to break down each term so then I can determine what everything has in common. So 6 is a number that I can break down with my factor tree. I want to think about numbers that multiply to 6 that is not 1 times 6. Well, that would be 2 times 3. I cannot break those numbers down any further because 2 is a prime number. That's just 1 times 2. 3 is a prime number. That's 1 times 3. Okay, once I have those numbers broken down, I know that 6y to the third is really 2 times 3, because that gets me 6. And then y to the third means that I get to multiply y 3 times. All right, if I look at the next term, you can ignore the subtraction sign. I want to focus on the 3. I can't break that down any further. The fact is 3 is just 1 times 3. So if you want, you can put the 1, but it's 3. And then I see 1y. So now that I've listed out every single thing in terms of my factors, remember GCF, greatest common factor. So the biggest number that divides each term. So I'm going to look at all of the numbers in my rows, and if they have the same number, I'm going to highlight it. So I see a 2 in the top row, but I don't see a 2 in the bottom row. I see a 3 in the top row, and I see a 3 in the bottom row. That's why I get to highlight that. They have something in common, greatest common factor. So when they have something in common, I know that that's going to be a part of the GCF. Now, because I don't have any other numbers that they both have in common, the only number that I highlighted was a 3. I don't write that 3 twice. It's 1 3 on the top and it's 1 3 on the bottom because they have 1 3 in common. So my GCF is going to contain a 3. Once I've taken care of the numbers, now I look at the variables. I see that there's a y on the top and there's a y on the bottom. I see that there's another y on the top, but I've run out of variables. Since there are no more variables, I cannot keep highlighting. So because there's one y on top and one y on the bottom, they have one y in common. So that is also a part of the GCF. So between 6y to the third and this negative 3y, they have a 3y in common. That's my GCF. If we take a look at this second example, we've got 8x squared plus 12y. So I want to start breaking up my numbers. 8 is really 4 times 2. I can't break up 2 any further, but I can break up 4. That's 2 times 2. So I know that 8x squared, if I multiplied out my numbers, it's only the numbers that I have circled. If I multiply 2 times 2 times 2, that's going to get me 8. So since 4 isn't circled because we broke it down, cross it off. That's not going to go on my list of common factors. I also have x squared, so that means I want an x times an x because there's 2 of them. Now I'm going to move over to the 12. So now I want to figure out, how do I break down 12? There's a lot of ways to break down 12. One of them is 2 times 6. I can't break down 2 any further. 6 I can. 6 is 2 times 3. So because I broke down the 6, I'm not using that. I'm only going to list the numbers that are circled. So 12 is the same thing as 2 times 2 times 3. You can even verify that. If you actually multiply those 3 numbers, you should get 12. If you had put the 6 in there as well, if you multiplied them, you're not going to get 12. So that kind of is how you to verify that you are putting down the correct numbers. There's a y with this, so I'm going to put the y after. Okay, so remember, I want to figure out the GCF. What do they have in common? So I'm going to start with my numbers. I see that they have a 2 on the top and a 2 on the bottom. So they have 1, 2 in common. They have another 2 on the top, and they actually have another 2 on the bottom. So I get to highlight a second set of 2s. I see another 2 on the top, but I have no more 2s on the bottom. So I can't highlight that 2. I have a 3 on the bottom, but I have no 3s on the top. So I can't highlight that 3. So it looks like because I highlighted 2 sets of 2s, 2 times 2 is going to be my GCF. So 2 times 2 is 4. Because the variables on the top are X and the variable on the bottom is a Y, there's no letters that they have in common. So that just tells me that my final answer, my GCF, is the number 4. Okay, so sometimes you might have the same number repeated multiple times, but that's something that's shared between both of the rows. So if it's not shared with both of the rows, like in the first one, you can only write the 3 once. But since I highlighted 2 pairs, 2 times 2 got me my answer. All right, so I would suggest you pause the video and try this checkpoint problem. Find the GCF of 12mn minus 3m to the 4th. So the 12 I can break up into 4 times 3, and 4 is 2 times 2. Or you could have done like the last example and done 2 times 6. But I get a cross off the 4 because I broke it up into 2 and 2. So I know that 12mn is 2 times 2 times 3, and then that's times m times n. The 3 I can't break up any further. So if you want, you can think of it as 1 times 3, but then there's 1, 2, 3, 4 m's. So if I start looking at my numbers, I see a 2 on the top, but I don't see a 2 on the bottom, so I can't highlight that first 2. Same thing with the second 2. It's on the top, but it's not on the bottom, can't highlight it. The 3 on the top has a 3 on the bottom, so that gets to get highlighted. Because there are no other numbers, I know that my GCF has 1 pair of 3s. So 1, 3 is what they have in common. If I look at my letters, I have an M on the top and I have an M on the bottom. My next letter is an N on the top, but there is no N on the bottom. I have more M's on the bottom, but I don't have any more M's on the top. So I only could highlight 1 pair of M's, so 1M is also a part of my GCF, and that'd be my answer.